On April 13, 1970, astronaut Jack Swigert looked at a warning light on his instrument panel 200,000 miles from Earth and his heart sank. He pressed the button to send a message to Mission Control in Houston. His voice was calm, professional, almost casual. "Houston, we've had a problem." Those 6 words would become among the most famous in the history of space exploration. Because the problem Swigert was reporting wasn't a minor glitch or a routine malfunction. An oxygen tank had just exploded on the Apollo 13 spacecraft. The command module was dying. Power was failing. Oxygen was venting into space. And 3 men were stranded in a crippled spacecraft further from home than any human beings had ever been when disaster struck. NASA had expected Apollo 13 to be routine, almost boring. The third moon landing in less than a year. The public had already lost interest after Apollo 11 and 12 succeeded. Television networks weren't even covering the mission live anymore. Nobody was watching. But over the next 4 days, the entire world would watch as 3 astronauts and thousands of NASA engineers fought to do something that seemed impossible. Bring a dead spacecraft home across 250,000 miles of empty space. Turn a lunar module designed for 2 men and 45 hours into a lifeboat for 3 men for 4 days. Build a carbon dioxide scrubber using only duct tape, cardboard, and plastic bags. And restart a frozen command module that was never meant to be shut down in space. This is the story of Apollo 13. The mission that was supposed to land on the moon. The explosion that nearly killed 3 men. And the rescue mission that NASA would later call a successful failure. When Apollo 13 launched on April 11, 1970 from Kennedy Space Center in Florida, nobody expected anything unusual. NASA had gotten good at sending men to the moon. Apollo 11 had landed Neil Armstrong and Buzz Aldrin on the lunar surface in July 1969. Apollo 12 followed in November. Both missions were complete successes. Apollo 13 would be different in only one way. The landing site. Commander James Lovell and lunar module pilot Fred Haise would land at Fromaro, a hilly region of the moon that scientists wanted to explore. They'd collect rock samples, set up scientific instruments, and return home heroes. It was all planned down to the minute. The crew was experienced. Jim Lovell was 42 years old, and this was his 4th space mission. He'd flown on Gemini 7, Gemini 12, and Apollo 8, which had orbited the moon without landing. Lovell was scheduled to be only the 5th person to walk on the moon. He'd been to space more than almost anyone and had more hours in space than any other astronaut. Fred Haise was 36, a former Marine and Air Force pilot. This was his first spaceflight, but he'd trained for years. He was the lunar module pilot, responsible for flying the LM down to the moon's surface. And then there was Jack Swigert. He was 38, a former Air Force pilot who'd been with NASA since 1966. But here's the thing. Swigert wasn't supposed to be on this mission at all. The original command module pilot was Ken Mattingly. The 3 of them, Lovell, Haise, and Mattingly, had trained together for months. They were a crew, a team. But just days before launch, disaster struck. Charlie Duke, the backup lunar module pilot, came down with German measles. And he'd exposed the prime crew. NASA doctors tested everyone. Lovell and Haise were immune. They'd had measles as children. But Mattingly had never been exposed. If he got sick on the way to the moon or during the landing, it would be a catastrophe. NASA made the agonizing decision to pull him from the crew just 72 hours before launch. Jack Swigert was the backup command module pilot. He got the call that he was going to the moon. 3 days to prepare for a mission that takes months to train for. 3 days to integrate with a crew that had worked together for half a year. Swigert would later say it felt like being thrown into the deep end of a pool. Launch day was April 11th. The Saturn V rocket, the most powerful machine ever built, lifted off at 2:13 p.m. Houston time. The launch number was 13. The date added up to 13. Some people muttered about bad luck. Commander Lovell, whose grandfather had been Italian, dismissed the superstition. In Italian culture, 13 was a lucky number. The launch went smoothly except for one thing. 5.5 minutes into the flight, the center engine of the second stage shut down early. The rocket compensated automatically, burning the other engines longer. Lovell felt the spacecraft shaking more than it should have, but they made it to orbit. Engineers on the ground looked at the data and decided it wasn't serious. The mission continued. For the next 2 days, everything went according to plan. The spacecraft left Earth orbit and began the long coast to the Moon. Apollo 13 was actually 2 spacecraft joined together. The command module, called Odyssey, where the astronauts lived and which would eventually bring them home. And the lunar module, called Aquarius, which would land Lovell and Hayes on the Moon while Swigert orbited above in Odyssey. The astronauts settled into the routine of spaceflight. They ate, slept, performed systems checks, sent TV broadcasts back to Earth showing viewers what it was like inside the spacecraft. But nobody was watching. The TV networks didn't even carry the broadcasts live. America had been to the Moon twice already. Apollo 13 was old news. On the evening of April 13th, 55 hours and 54 minutes into the mission, Jack Swigert got a routine request from Mission Control. They wanted him to stir the cryogenic oxygen tanks. These tanks held super-cold liquid oxygen that provided breathable air for the crew and powered the fuel cells that generated electricity. Stirring them meant turning on fans inside the tanks to agitate the liquid, which gave Mission Control accurate readings of how much oxygen remained. It was a procedure they'd done many times before. Nothing complicated. Nothing dangerous. Swigert flipped the switch. 9 seconds later, at 55 hours 55 minutes mission elapsed time, the crew heard a loud bang. The entire spacecraft shuddered. Warning lights lit up across the instrument panel. Lovell looked at Hayes. What the hell was that? Swigert pressed the button to call Mission Control. Houston, we've had a problem. In the Mission Control room in Houston, Flight Controller Cy Liebergott stared at his console in disbelief. The telemetry data streaming back from Apollo 13 didn't make sense. Oxygen Tank 2 was reading 0. Fuel Cell 3 was offline. Voltage was dropping across the entire electrical system. Something catastrophic had happened, but what? On board the spacecraft, the crew was trying to figure out the same thing. They looked out the windows and saw something terrifying. A cloud of gas venting into space, glittering in the sunlight. Something was leaking. And in space, leaks are deadly. What the astronauts and Mission Control didn't know yet was this. Oxygen Tank 2 had exploded. Not just failed. Exploded. The blast had ripped open one entire side of the service module, the cylindrical section behind the command module that held the oxygen tanks, fuel cells, and other critical systems. Oxygen Tank 1, which had survived the blast, was now leaking through damaged lines. Within hours, all the oxygen in the service module would be gone. No oxygen meant no fuel cells. No fuel cells meant no electricity. No electricity meant Odyssey, the command module, would die. And without Odyssey, the astronauts had no heat shield to survive re-entry into Earth's atmosphere. Even if they made it home, they'd burn up trying to land. In Mission Control, Flight Director Gene Kranz called his team together. "We have a situation," he said. "Work the problem, people. Don't make it worse by guessing." Kranz was legendary for his cool under pressure. He'd been a flight director since the early days of the space program. He wore a vest his wife sewed for every mission, a different one each time for good luck. Today's vest was white. The first question was simple. Could they still land on the Moon? The answer came back immediately. No. Absolutely not. The service module was dying. Landing was impossible. The new mission was survival. Get the crew home alive. But how? Odyssey was losing power by the minute. The oxygen that remained in the command module was needed for re-entry. They couldn't waste it. Flight surgeon John Aaron made the call. Shut down Odyssey completely. Power down everything. Put the crew in the lunar module and use it as a lifeboat. The lunar module Aquarius had its own oxygen supply, its own power system, its own life support. It was designed to support 2 men for 45 hours while they explored the Moon's surface. Now it would have to support 3 men for at least 90 hours, probably longer, while they traveled 250,000 miles home. Lovell, Hayes, and Swigert moved into Aquarius, sealing the hatch behind them. It was cramped, barely big enough for 2 people, now holding 3. They shut down Odyssey completely, preserving its battery power for the one moment they'd need it most. Re-entry. if they made it that far. In Houston, hundreds of engineers were working the problem. How do we get them home? The spacecraft was already past the moon. They couldn't just turn around. The physics didn't work that way. There wasn't enough fuel to reverse course and come straight back. The only option was to loop around the moon. Use the moon's gravity to slingshot Apollo 13 back toward Earth. It was called a free return trajectory. The spacecraft would swing around the far side of the moon and gravity would send it home. But there was a catch. The trajectory wasn't perfect. They'd have to fire the LM's engines at precise moments to make course corrections, or they'd miss Earth entirely and drift off into space forever. On April 14th, while Apollo 13 was behind the moon and out of radio contact, Lovell and Hayes fired Aquarius's descent engine for 35 seconds. It was a critical burn, adjusting their trajectory to speed up the return. When Apollo 13 came back around the moon and re-established contact with Houston, Mission Control held its breath. Had it worked? The telemetry came through. Perfect. The burn had been exactly right. But they weren't safe yet. Not even close. Inside Aquarius, the three astronauts faced a new crisis. The temperature was dropping. The lunar module wasn't designed to run for days at a time. To conserve power, they turned off everything non-essential. No heaters. The temperature inside Aquarius fell to 38 degrees Fahrenheit. Just above freezing. The astronauts wore thin flight suits. No jackets. No blankets. They were shivering constantly, unable to sleep, unable to stay warm. Water condensed on every surface, dripping from the walls, making everything damp and cold. Lovell would later say it was like living in a refrigerator for 4 days. Food was scarce. They had some rations, but not enough for 3 men for this long. Water was even more critical. They rationed themselves to 6 ounces per man per day. 6 ounces. Not even a cup. Try living on that. Try functioning, staying alert, making life or death decisions while freezing and dehydrated. Jack Swigert developed a kidney infection from the lack of water. He was in pain but said nothing. What could Houston do about it? Nothing. He suffered in silence. Then came the carbon dioxide problem. Every time a human exhales, they release carbon dioxide. In a closed spacecraft, that CO2 builds up. Too much and it becomes toxic. You pass out, then you die. Spacecraft have scrubbers, canisters filled with lithium hydroxide that absorbs CO2 from the air. Aquarius had scrubbers, but they were designed for 2 men for 2 days. Now they had 3 men and it had already been 3 days. The CO2 levels inside Aquarius were rising to dangerous levels. The crew was getting sluggish, dizzy, struggling to think clearly. They needed more scrubbers. And there were scrubbers available. In Odyssey, the command module. But there was a problem. The command module scrubbers were square. The lunar module system required round scrubbers. You couldn't just swap them. They didn't fit. In Mission Control, a team of engineers gathered in a room with a box. Inside the box was everything the astronauts had available on the spacecraft. Duct tape, plastic bags, cardboard, hoses from spacesuits, socks, anything and everything. The engineers were told to build a square scrubber that would fit into a round hole using only what was in that box. They worked for hours, trying different configurations, testing, failing, trying again. Finally, they had it. A Rube Goldberg contraption made of plastic bags, cardboard covers torn from procedure manuals, duct tape holding it all together, and a hose from a spacesuit to channel air through it. It looked absurd. But when they tested it, it worked. Mission Control radioed up detailed instructions. The astronauts followed along, building their own version of the makeshift scrubber. It took about an hour. They taped it together, connected it to the system, and turned it on. Everyone watched the gauges. The CO2 levels started dropping. The contraption worked. Crisis averted. For now. Day followed freezing, miserable day. The astronauts drifted through space, curving around behind the moon, heading for home. Another course correction burn was needed. This one was critical. If they missed Earth, if the trajectory was off even slightly, they'd either burn up in the atmosphere coming in too steep, or skip off the atmosphere like a stone on water and drift into space forever. On April 15th, Fred Hayes manually aligned the spacecraft using the Sun and Earth as reference points. No computer navigation. Just eyeballs and skill. Then they fired the engine for just over 4 minutes. It had to be perfect. Lovell and Hayes held their breath. When it was done, they radioed Houston. The burn had gone exactly as planned. They were on course for Earth. But the most dangerous part was still ahead. Re-entry. To survive re-entry, they had to power up Odyssey, the command module. It had been shut down for nearly 4 days. It was frozen solid. Ice covered the windows. Condensation had soaked into electrical panels. The entire spacecraft was a giant cold, wet, short circuit waiting to happen. Normally, powering up the command module took hours and a thick checklist. They didn't have hours. They had about 2 hours before they hit the atmosphere. And the checklist assumed everything was working normally. Nothing was normal about this. Ken Mattingly, the astronaut who'd been bumped from the crew because of measles exposure, was working around the clock in a simulator in Houston. He'd never gotten sick, by the way. He was perfectly healthy. And now he was using that simulator to figure out how to power up a frozen spacecraft with minimal power in minimal time. Mattingly and flight controller John Aaron developed a procedure. It was untested. It was risky. If something shorted out when they powered up, it could kill the command module completely and the crew would die on re-entry. But they had no choice. On the morning of April 17th, with less than 6 hours until re-entry, Swigert moved back into Odyssey and began the power-up sequence. He followed Mattingly's instructions radioed up from Houston. Flip this switch. Wait. Check the reading. Good. Next switch. It was agonizing. Every moment, they expected something to fail, to short out, to explode. But it didn't. Slowly, incredibly, Odyssey came back to life. The instruments powered on. The guidance system booted up. The batteries were holding. It was working. They had a functioning command module. 3 hours before re-entry, the astronauts jettisoned the service module. They wanted to photograph the damage, to see what had happened. When the service module drifted away and they got their first clear look, Lovell was stunned. One entire side of the service module was gone. Blown apart. One whole side of the spacecraft is missing, Lovell radioed to Houston. How they'd survived with that kind of damage, how anything had kept working, was a miracle. If the explosion had happened earlier in the mission, or if it had ruptured a different tank, or if any one of 100 things had gone slightly differently, all 3 men would have died instantly. 1 hour before re-entry, they jettisoned Aquarius, the lunar module that had saved their lives, the lifeboat that had kept them alive for 4 days. They sealed the hatch, separated from it, and watched it drift away. Lovell would later say it was the saddest moment of the mission. Aquarius had gotten them home, and now they had to let it go. It would burn up in Earth's atmosphere, just like they might if anything went wrong in the next few minutes. The 3 astronauts were now in Odyssey, strapped into their seats, heading for the atmosphere. Re-entry is always dangerous. You're hitting the atmosphere at 25,000 miles per hour. The heat shield on the bottom of the spacecraft heats up to 5,000 degrees Fahrenheit. You're essentially a meteor, a ball of fire streaking across the sky. If the angle is too steep, you burn up. Too shallow, you bounce off. It has to be perfect. And there was another concern. Had the explosion damaged the heat shield? Nobody knew. The heat shield was on the bottom of the command module, protected by the service module during flight. When they jettisoned the service module, they'd seen the massive damage. Had any of that damage affected the heat shield? If it had, even a small crack or hole, Odyssey would burn up on re-entry and the crew would die. During re-entry, there's always a communications blackout. The plasma field generated by the heat of re-entry blocks radio signals. For about 4 minutes, Mission Control loses all contact with the spacecraft. 4 minutes of silence. Then, if everything goes right, the parachutes deploy and the spacecraft splashes down in the ocean. 4 minutes can feel like forever when you're waiting to know if 3 men are alive or dead. Apollo 13 hit the atmosphere on schedule. Radio contact was lost. Mission Control stared at their consoles. In the viewing room, NASA officials, astronauts, and media watched the clock. 4 minutes. That's how long blackout normally lasts. Maybe a little longer. 4 minutes passed. No signal. Silence. Gene Kranz stood at his console, face expressionless, but inside his stomach was churning. 5 minutes. Still nothing. 6 minutes. The room was completely silent. If the heat shield had failed, they'd never hear from the crew again. They'd just be gone. Then, at 6 minutes, a voice crackled over the speakers. "Odyssey, this is Mission Control. Do you read?" Jack Swigert's voice, calm as ever, came back. "Hello, Houston, this is Odyssey. It's good to see you again." Mission Control erupted. People were cheering, crying, hugging each other. In the viewing room, grown men wept openly. On TV screens around the world, broadcasters struggled to keep their composure as they announced that the crew was alive, the parachutes had deployed, Apollo 13 was coming home. At 1:07 p.m. on April 17, 1970, 6 days after launch, the Apollo 13 command module splashed down in the Pacific Ocean near Samoa. The USS Iwo Jima, an aircraft carrier, was waiting. Helicopters lifted off immediately, racing to the splashdown site. 45 minutes later, Jim Lovell, Fred Hayes, and Jack Swigert were standing on the deck of the Iwo Jima. They were thin, exhausted, dehydrated, suffering from exposure and infections. But they were alive. They were home. Around the world, an estimated 40 million Americans and hundreds of millions more across the globe had watched the final hours of Apollo 13. The mission that nobody had cared about when it launched had become the most watched space mission in history. Not because it succeeded in landing on the moon, but because 3 men and thousands of NASA engineers had refused to give up when death seemed certain. NASA Administrator Thomas Paine immediately appointed a review board to investigate what had happened. The board was chaired by Edgar Cortright and included Neil Armstrong among others. They spent weeks examining the spacecraft, reviewing telemetry data, interviewing everyone involved. The conclusion was damning but also enlightening. Oxygen Tank 2 had a troubled history. It had originally been installed in Apollo 10 but was removed for modifications. During a test at Kennedy Space Center, the tank had been dropped, damaging internal components. Nobody noticed. The tank was installed in Apollo 13. Then, during a pre-launch test, there was a problem emptying the tank. Technicians used the tank's internal heaters to boil off the remaining oxygen. They left the heaters on for 8 hours. The heaters were designed for the command module's 28-volt system, but the ground support equipment used 65 volts. The excessive voltage damaged the Teflon insulation on wiring inside the tank. When Jack Swigert flipped the switch to stir the tanks, those damaged wires shorted out. The short ignited the Teflon insulation. In a tank full of pure oxygen, fire spreads instantly. The tank exploded. A cascade of small mistakes and oversights, none of them caught, all of them combining to create a disaster. The review board made extensive recommendations. Redesign the oxygen tanks. Remove the internal fans and stirring mechanisms. Add a third oxygen tank that could be isolated. Change the thermostats and heater tubes. Increase battery capacity in the lunar module. All of these changes were implemented immediately. The remaining Apollo missions, 14 through 17, incorporated the lessons learned from Apollo 13, and none of them experienced similar problems. Jim Lovell, Fred Hayes, and Jack Swigert never flew in space again. NASA offered Lovell command of Apollo 17, but he would have had to wait over 2 years. He declined. He'd been to space 4 times, orbited the moon twice, and survived a disaster that should have killed him. He retired from the Navy and NASA in 1973. Fred Hayes was assigned to Apollo 19, but that mission was canceled as NASA wound down the Apollo program. He moved into the Space Shuttle program, testing the orbiter during landing approaches. He eventually left NASA and worked for Grumman, the company that had built Aquarius, the lunar module that saved their lives. Jack Swigert was elected to Congress in 1982 but died of cancer before he could be sworn in. He was only 51 years old. Ken Mattingly, who'd been pulled from the crew and never got measles, finally made it to the moon on Apollo 16 in 1972. He also flew 2 space shuttle missions. When people asked him about Apollo 13, about being bumped from the crew, he'd say he was grateful. Grateful he'd been in Houston where he could help bring his friends home. Gene Kranz continued as a flight director through the Skylab and Space Shuttle programs. He became a legend at NASA, known for his leadership during Apollo 13. His motto became famous: "Failure is not an option." Though he's admitted he never actually said those exact words during the mission. But the spirit was accurate. Giving up was never considered. In 1995, director Ron Howard made a film about Apollo 13 starring Tom Hanks as Jim Lovell, Kevin Bacon as Jack Swigert, Bill Paxton as Fred Hayes, and Ed Harris as Gene Kranz. The movie was a massive success, winning 2 Academy Awards and introducing the Apollo 13 story to a new generation. The phrase "Houston, we've had a problem" became part of popular culture, though the movie slightly changed it to "Houston, we have a problem." The real quote was past tense, "had a problem," because by the time Swigert made the call, the explosion had already happened. NASA came to call Apollo 13 a successful failure. They failed to land on the moon. They failed to complete the mission objectives. But they succeeded in the most important goal of any space mission. They brought the crew home alive. The mission proved that NASA could handle a crisis. That the thousands of engineers, flight controllers, and support staff weren't just following procedures. They could think on their feet, improvise solutions, work around the clock to solve problems nobody had ever faced before. It proved the astronauts were more than pilots. They were test pilots, yes, trained to stay calm in emergencies, to work through checklists under pressure. But they were also innovators, building carbon dioxide scrubbers from duct tape and plastic bags, manually navigating by the stars, surviving in conditions they'd never trained for. The Apollo 13 story resonates because it's about ordinary people, or at least people doing extraordinary jobs, facing impossible circumstances and refusing to quit. 3 astronauts freezing in a disabled spacecraft, rationing water, breathing recycled air, trusting that people 200,000 miles away could figure out how to get them home. And those people in Houston, working around the clock, sleeping at their consoles, running simulations, testing procedures, building carbon dioxide scrubbers in conference rooms, calculating trajectories, talking the crew through power-up sequences, never giving up, never accepting that those 3 men were going to die. When Apollo 13 splashed down, when Lovell, Hayes, and Swigert walked onto the deck of the Iwo Jima, it wasn't just their victory. It was a victory for everyone who'd worked the problem. Everyone who'd refused to accept failure. The Apollo program continued for 3 more missions after Apollo 13. Apollo 14 landed at Framaro, completing the mission Apollo 13 had planned. Apollo 15, 16, and 17 conducted extended explorations, bringing back hundreds of pounds of moon rocks and advancing scientific knowledge enormously. But many people believe Apollo 13 was the most important Apollo mission of all. Not because of what it accomplished in space, but because of what it revealed about human capability here on Earth. That when faced with impossible problems, when lives hang in the balance, human beings can achieve the impossible. Jim Lovell was asked once if he had any regrets about Apollo 13, about not landing on the moon, about coming so close and missing his chance to walk on the lunar surface. He said no. He said Apollo 13 was the mission he's proudest of. Not because it went according to plan, but because when everything went wrong, when disaster struck, he and his crew and everyone at NASA did everything right. That's the legacy of Apollo 13. Not the explosion. Not the near disaster. But the rescue. The ingenuity. The refusal to give up. The successful failure that proved NASA could bring astronauts home even when all hope seemed lost. And somewhere, still in orbit or perhaps crashed long ago on a distant asteroid, is Aquarius. The lunar module that was supposed to land at Framaro. The little spacecraft that became a lifeboat. The ship that saved 3 lives and wrote one of the most incredible chapters in the history of human spaceflight. Houston, we've had a problem. Yes, they had. And they'd solved it, against all odds, bringing 3 men home alive across 250,000 miles of space. That's not just a successful failure. That's a triumph.